We're now on example 5, section 4.3, quadratic functions and their properties. In example 5, they've given us a graph, and from this graph, we are supposed to write the function. It may be a little hard to read the graph, so I'm going to come back through here and indicate that the vertex here is the point -1, -4. We have a y-intercept of the point 0, -3, and two x-intercepts, -3, 0, and 1, 0. Okay, so what we have to do to start is to know that vertex form, f of x equals a times x minus h squared plus k, where h and k are the vertex, and a is a multiplier, right? It might make it, stretch vertically or compress vertically, depending on what it is. And it could be 1, right? But we don't know. So this is what I know this and I know this. So I know h and k, right? So they tell us hk is -1, -4. hk is -1, -4. So I've got those two. And I have this point 0,3. So I could use the point 0,3 in this function. Let me write it here. So if I have the point 0, -3. So here is an x that's on the graph. It satisfies this equation, this function, and here's an f of x. So in other words, I have an f of x, I have an x, I have h, I have k, I have everything but a. So if I plug all those things in, I can solve for a and then come back and write my function. So if I substitute -3 for f of x, I don't know what a is. I know that 0 is on the graph. This point 0, -3, 0, -3. And then it says minus h, minus, my h is -1. That gets squared, and then I add -4. And I'm doing this so I can find a, then I'll go back and write the function. All right, so I have -3 equals a times 0 minus -1 is just +1 or 1, and 1 squared is 1, minus 4. So what I have is -3 equals a minus 4. Add 4 to both sides, and in this case, a is 1. It's not always, so you have to go through the steps to find out. So here we have found it. This function is f of x equals 1 times, but I'm not going to write that, the 1, it's understood, x minus h is -1, so x plus 1 squared minus 4. There's the function for this graph. Notice we did not need to use the x-intercepts. I needed a point on the graph, that's not an x-intercept, and the vertex, and I could find a and write the function. If I had found like a equals 3, I would have a 3 right here in front, but I didn't. Okay, note if a is positive, greater than 0, the vertex is so if a is greater than 0, what do we know about the parabola? It opens up, and how would you describe the vertex? It's the what point on the parabola since it opens up? If it opens up, the vertex is the lowest point, right? This means that the lowest that we reach, the lowest that parabola goes, is to k, right? The minimum value of the function, in this example, it was -4. That's the lowest we go. We go down to -4. So k, our vertex is hk, right? So k is our minimum value. If a is negative, then remember our parabola opens up, so the vertex would be the highest point on the parabola. And now, if it's opening down like this, then k would be our maximum value of the function. All right, so let's work a problem about max and min value. Determine whether the quadratic function has a max or min value. Which one is it, max or min? And then find it. Okay, so a here equals -1. That means it opens down. So that means it would have a maximum value, right? How high up does this graph go, this function? That's the question. And the direction vertically is the y coordinate of the vertex. So that's what we have to do. To find the max value, this is the y coordinate of the vertex. That's what we're looking for. Some people want to give the vertex as the answer. That's incorrect. It's not a point, xy point. It's the y coordinate of the vertex. So we want to find k, the y coordinate, right? So how do we do that? How have we done it every time? Start with x equals negative b over 2a. We have to find the x coordinate first, right? That's what we've done every time. So negative 4 over 2 times negative 1. Negative 4 over negative 2, 2. This is not the answer. This just tells us where we are horizontally. That's not a max or min value. Now we find f of 2. Negative 2 squared plus 4 times 2 plus 5. So we have what? Negative 4 plus 8 plus 5. So that's 4 plus 5 are 9. So the maximum value is 9. It's a number. It's not an ordered pair. Okay?